Hi everyone, welcome to the first session of chapter 1 sets of +1 mathematics. Let's see the mathematician who developed the set theory and what are its uses. The theory of sets was developed by German mathematician George Cantor. He first encountered sets while working on problems on trigonometric series. Sets are used to define the concept of relations and functions. Also, the study of geometry, sequences, probability, etc. requires the knowledge of sets. Let's see the contents of this topic. Set, representation of the set, empty set, finite and infinite sets, equal sets, subsets, singleton set, power set, intervals as a subset of real numbers, Venn diagrams, operations on set. Let's see one by one. The set in our everyday life, we discuss the collection of objects like pack of cards, team of players, group of people, etc. Similarly, in mathematics also, we have the collection of numbers like real numbers, even numbers, odd numbers, etc. So, this so-called well-defined collection is called as a set. So, we can define the set as a set is a well-defined collection of objects. A set is defined as a well-defined collection of objects. Like examples, the rivers in India is a set, vowels in English alphabets, even numbers less than 10, members in our family. Like this, we can come out with many examples of set, and it should be well defined. Now, make a note. The objects can also be called as elements or the members of the set. Set is actually well-defined collection of objects. So, when you are asked to give examples of 5 most renowned mathematicians or 10 most talented writers or a team of 11 best cricket batsmen of the world, they are not well defined. The reason is the word talented, the best, beautiful differs from person to person. So, as they are not well defined, we don't call them as sets. How do we represent set? Let's see. Set is usually represented by capital letter A, B, C, D, etc. Similarly, we can represent the elements or object or members of the set by the small letter A, B, C, D, etc. Now, if A is an element of A, we say that A belongs to A, and we write it as A belongs to symbol A. Similarly, if B is not an element of the set A, we say that B does not belong to A, and we write it as B does not belong to symbol is this A. Now, consider the example. Consider set A of prime factors of 12. We know that the factors of 12 are 1, 2, 3, 4, 6 and 12. So, here you are asked to find the prime factor. So, when we are discussing the prime factor, I can say that 2 belongs to the A because 2 is a prime number, and 6 does not belong to A because 6 is not a prime number. Now, some examples of the set which we use in mathematics. Capital N the set of natural numbers. Capital Z, the set of all integers. Capital Q, the set of all rational numbers. Capital R stands for the set of all real numbers. Z raised to plus sign means the set of positive integers. Q raised to plus sign, the set of positive rational numbers. R plus, the set of positive real numbers. Now, how do we represent a set? What are the methods of representing a set? We have got two methods. One is roster or tabular form. The second method is set builder form or statement form. Let's see one by one. Roster or tabular form. It means all the elements are listed, separated by commas within the braces. We write within the braces. So, roster form means we are listing down the elements separated by commas enclosed between the braces. For example, let's see set of vowels in English alphabet. So, we know that the vowels are A, E, I, O, U. So, how do you write it in the roster form? Within braces, we write it as A, E, I, O, U. So, you have listed down the elements separated by commas enclosed within the braces. Next example, set of all letters in the word better. Set of all letters in the word better. So, you have to note down one thing, that in the set, an element comes only once. We need not repeat the element twice or more than that. Similarly, the order of the arrangement doesn't matter. So, here the letters will be B, one E, one T is taken R. Therefore, it can be written within the braces, written as B, E, T, R. Next example, set of positive integer x such that x squared is less than 40. You are asked to write down the set of integer such that the squares of that number should be less than 40. So, we know that 1 squared, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. We cannot take 7 square because it exceeds 40. So, what will be the answer? So, within braces, you can write 1, 2, 3, 4, 5, 6. Next example, set of integers such that x square minus 16 is equal to 0. You are asked to find the set of integers such that x square minus 16 equal to 0. So, x square minus 16 equal to 0 means x squared is equal to 16. So, x is equal to plus or minus 4. So, how do we write in the roster form? Within braces, minus 4, plus 4. Next, we will see to the set builder form or statement form. So, in the set builder form, all the elements possess a common property which is not possessed by any other element outside the set. So, all the elements possess a common property. For example, let us consider the set of vowels A, E, I, O, U. We can see that each letter is a vowel in this, and we don't have any other vowel outside this set. So, how do we represent this in the set builder form? So, we write it as set A is equal to the set of all x such that x is a vowel in English alphabet. So, you are writing in the statement form, set of all x such that X is a vowel in English alphabet. We'll see two more examples. First one, A is equal to the set 2, 4, 8, 16, 32. We are asked to write this in the set builder form. First, we'll see to the common property in that set. So you can see the first element is 2, which is 2 raised to 1. Second element is 4, that is 2 square. Third element is 8, that is 2 cube. Fourth element is 16, 2 raised to 4, and 32 is 2 raised to 5. So how can we write in the set builder form? Set of all x such that x is equal to 2 raised to n, where n belongs to capital N, that is the set of natural numbers, and n lies between 1 and 5, which we write it as 1 less than or equal to n less than or equal to 5. Next example, A is equal to the set 1, 4, 9, 16, 25, etc. So let's check for the common property that is existing in that set. You can see that the first number is 1 square, second number is 2 square, third number is 3 square, and fourth number is 4 square, etc. So I can write it in the set builder form as set of all x such that x is the square of a natural number. Next example, the set 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6, 6 by 7. So let's analyze this. The first number is numerator is 1, denominator is 1 plus 1, that is 2. The second term, numerator is 2, denominator is 2 plus 1. In the third term, numerator is 3, denominator is 3 plus 1, that is 4. In the fourth term, the numerator is 4 and the denominator is 4 plus 1, 5. In the fifth term, numerator is 5 and the denominator is 5 plus 1, that is 6. And sixth term, numerator is 6 and denominator is 6 plus 1, that is 7. So you can see that the numerator, so for n, it will be, numerator will be n and denominator will be n plus 1. So which we can write it as A is equal to set of all x such that x is equal to n by n plus 1, where n is a natural number and n lies between 1 and 6. That is 1 less than or equal to n less than or equal to 6. Okay. Now, there are different types of sets. Let's see one by one. First is the empty set. When we say empty set, in the word itself, empty, no element exists. So, empty set can be defined as a set which does not contain any element is called as the empty set. How do we represent the empty set? Either by the letter phi or within braces, since no element exists, only the braces we put. And the empty set is also called as void set or null set. Let's see to some examples of empty set. So, if somebody is asking you to say a natural number between 1 and 2 or 2 and 3 or 3 and 4, we can never say it because between two natural numbers we don't have another natural number. They're all real numbers. So, between 4 and 5 or 1 and 2 or 2 and 3, if you're asked to find a natural number, it is an empty set because no such natural number exists. Next example, the set of all x such that x is an even prime number greater than 2. We know that 2 is the only even prime number and 2 is the least prime number. So, greater than 2, we don't have any even prime numbers. So, that is also an empty set. Next, consider the example. set of all x such that x squared equal to 16. The condition is that x should be odd. So we know that when x squared is equal to 16, x is equal to plus 4 or minus 4, which is not an odd number. So that is also an empty set. See the next example, set of all x such that x is a natural number and 3x minus 1 equal to 0. So when you solve 3x minus 1 equal to 0, the resulting answer should be a natural number. So let's see, when 3x minus 1 is equal to 0, we get 3x is equal to 1, which means x is equal to 1 by 3, and surely it is not a natural number. So this is again an empty set. Next, we'll talk about finite sets and infinite sets. From the word itself, it's understood finite. The set where you are able to count the elements. So we can define the finite set as a set which is empty or consists of definite number of elements is called as the finite set. A set which is empty or consists of a definite number of elements is called a finite set. Otherwise, it is called as infinite set. Let's see to some examples of finite sets. Set of days of the week. So you're able to count Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. 7 days are there. So it is a finite set. Similarly, if I ask you to say the months of a year, so starting from January to December, you can say 12 months, you're able to count it. So it's a finite set. Similarly, if you're asked to write the set of the solution of the equation x squared minus 5x plus 6 equal to 0, it's a quadratic equation. You know that it has got a finite solution, say x minus 2 into x minus 3 equal to 0. So x is equal to the set 2, 3. They are finite. Then the set of all x such that x belonging to a natural number and 2x minus 1 equal to 0. So when 2x minus 1 is equal to 0, we get 2x is equal to 1. Naturally, what do you get from there? X is equal to 1 by 2, which is not a natural number. So this set is actually a empty set and it is a finite set, because as per the definition, a set which is empty or that consists of a definite number of elements is called as finite. Therefore, this set is an empty set and it is also a finite set. Let's see some examples of infinite sets. Set of all x such that x is a natural number and x is prime. So you know the prime numbers, 2, 3, 5, 7, etc. It goes on. Therefore, it is an infinite set. Set of points on the line. So when we draw a line, we know that line extends in both the direction. So the points on the line are infinite. Set of integers, infinite set. Set of real numbers, odd natural numbers, even natural numbers, etc. are all examples of infinite set. Next, we'll talk about the equal sets. When do you say two sets are equal? So let's see the definition. We say two sets are equal if they have same elements. Two sets are said to be equal if they have exactly the same elements. And how do you write it? A is equal to B. So otherwise, sets are said to be unequal and we write it as A not equal to B. We'll see to an example. Let A be a set such that, set of all x such that x is the letter of the word follow, F-O-L-L-O-W. B is a set of all x such that x is the letter in the word wolf, W-O-L-F. So we are asked to check whether A is equal to B. So let's list down the elements. We'll write this set in the roster form and we'll see whether both are having exactly the same elements. So let's write down A. So A as mentioned earlier, a letter should not be repeated more than once. The order doesn't matter. So the elements are F, one O is taken, one L is taken, and W. Let's write down the set B. What are the letters in B? W, O, L, F. Now compare these two sets. We can see that they have exactly the same elements. Therefore, what can we conclude? The set A and B have the same elements. Therefore, A is equal to B. We'll see to one more example. A is the set 2, 3. Let B be the set of all x such that x is a solution of x square plus 5x plus 6 equal to 0. Now the question is, are the sets equal? So A is a set 2, 3. So when you see x square plus 5x plus 6 is equal to 0, at a glance you can see 2, 3 are the solution x plus 2, x plus 3 equal to 0. So you may tend to write it as 2, 3, but here the question is x is the solution of the equation. So first let's solve the equation. So x square plus 5x plus 6 equal to 0 is equal to x plus 2 into x plus 3 equal to 0. Since you are asked to find the solution, you are supposed to find the value of x. So what is x? Minus 2 minus 3. Therefore, how can we write the set B? B is equal to the set minus 2 minus 3. A is the set 2, 3. So we see that A is not equal to B. So with this, we come to the end of the first session, and the remaining topics will be covered in the next session. Thank you.